Hi guys, welcome to my object-oriented programming video in Java. So we're going to go through all of the main concepts of object-oriented programming, and we're going to completely start from scratch, so it's going to be nice and easy to follow, and we're going to try and avoid use all these big terms that scare people very quickly. But for starters, let's talk about what object-oriented programming actually is. So essentially what it is, it's just a way of programming where you can organize your software design around data or objects rather than kind of like loads of different functions and methods. And an object is simply just something that you can kind of group things together with. So for example, in the real world, a pen is an object, right? And a pen has properties such as like the color of the pen, maybe the ink color, if it's got a lid, or if it's one of those like gel pens, etc. So these are properties, and objects also have methods that they do, such as for example, a mobile phone. The properties for a mobile phone would be like the color, the screen size, the model, the make, etc. And then the methods would be, you know, power on, make a call, open camera. These are all methods. These are things that a phone can do. Especially nowadays, it can do quite a lot. And properties are just kind of the way you view it, or the way you kind of design the phone, right? So let's start off right at the start. So object-oriented programming revolves around classes and objects. So what is a class? Well, a class is essentially a file in Java where you can kind of create a blueprint. So for example, that phone that we spoke about, if we were to create a class that represents the blueprint for a phone, let's just call this phone. And you see here, that's how we create a class. We right click this folder called source, we click new, and we click Java class. Then we give it a name, and then you can see it's generated this bit of code here that says public class phone. So now, as we just discussed, a phone has properties. So for example, it's got a make, which is a string. It's also got a model. It's also got a color. It's also got, let's just do double screen size. Simple as that, right? So this is the properties that make a phone, or some of the properties anyway. And now we're going to talk about what can a phone do. So for example, one of the methods would be turn on. So let's create a method that returns nothing and just put turn on. Okay? And this is just a very basic method, and we're just going to print a message that says phone is turned on. Just like that, right? We can even do another method, and it's going to be make a call. Okay. And we're just going to say calling someone. Nice and simple, right? So this is now a blueprint, because all phones have these properties and all phones can do this, right? So this is just representing what a phone, it's just describing a phone, okay? Now how do we create an object? So an object is an instance of a class. That might sound a bit confusing, but basically what we're doing is we're taking this blueprint. So what we're going to do is we're going to write phone, okay? Because that is the class that we want to create a copy of, but like actually build an object of, right? So we're going to write phone, and we're going to give it a name. So I'm going to call this let's say a Samsung phone, okay? And to create an object, we use a keyword. So a keyword are words like this. See how they're highlighted in orange? They're words that are already kind of used by Java, so you can't create a variable with that name because that name or that word is already used. So the keyword here is new, and you have to put new and the class that you're trying to create. So if we click phone, notice here it's created these brackets. So this, and then if we end it with a semicolon, what we've now done is we've created our first object. We've created a Samsung phone. So by writing new phone, we're creating a new version of this. So all these properties and methods can now be used by this Samsung phone. Okay, so now what we can do is we can actually do Samsung phone dot, and notice here we've got access to all the properties. So let's say we've got a black Samsung phone. Okay, we've also got a, oh well, we can also make this equal to Samsung for the make. We've also got model, let's say S22. What else have we got? Screen size. Not entirely sure what the screen size is off the top of my head, so we'll leave that one out. But so now we've set some properties against our Samsung phone. What else can it do? Well, we've also got methods. So you notice here we've got access to make a call. So if I now run this code, there we go. We can see that our Samsung phone is making a call. Also, we might want to probably turn it on first, but if we run this, and there we go, phone is turned on, right? And just to prove that these kind of properties are set on my Samsung phone, we can do this. So we can do, let's do color of phone, and then if we add our Samsung phone dot color, and then maybe we'll do let's say make of phone, and let's print out our make. That will do, I guess. So if we run this now, you'll see that our Samsung phone is like a physical object, right? We've given it some properties and we've filled it in, and you have methods that are related to a phone. So what we've done is we've grouped related bits of code into one file, into one class, right? We've not got turn on in another file, we've not got make a call in another file, we're grouping it together. And now this is actually leading into really nicely into one of the pillars of object-oriented programming, and that is encapsulation. Now that sounds a bit scary, sounds like a big word, but don't worry. What we've just done is we've encapsulated related properties and methods into one file, right? So we've encapsulated the properties of a phone and the methods of a phone into one file, right? So now the phone object here that we created, the Samsung phone, has already got access to everything it needs for the phone, right? We don't have another file which has other stuff. We don't have another class, another method somewhere else. It's all in one area. So that is why object-oriented is so powerful, because we're grouping related bits of data, so it's more manageable and it makes more sense to anyone reading the code. But yeah, let's go a bit more into encapsulation and what we can do with it. So for example, what you might have seen here is that we generate a new phone object. Now this here, this is called a constructor, okay? And a constructor is just literally the name of the class created. So what's Java's done behind the scenes is it's generated this. So let's do public phone, this. So notice here it says one usage, and if we click on that, it takes us here. So what is a constructor? Well, a constructor is literally constructing an object from this blueprint. So what we've done right now is we've generated a constructor for the phone. So by writing new phone, we've created a phone, and this is the code that does it. Literally, that's it. Simple as that. So this is what a constructor is. And the best thing we can do actually is we can create another constructor, and we do pretty much the exact same thing. So again, a constructor is just the name of the class. It's how you create the object, okay? So notice how we've now got two of the same thing, but we can actually create a phone with these properties directly. So for example, we've got make. So make is a string. We've got string model. Maybe that's it. Maybe when we create the object, notice how we're creating an empty object here. The Samsung phone was empty. It didn't have any properties on it, did it? We had to set it ourselves by doing samsung.colorBlack.makeSamsung.modelS22. But by providing a constructor and using another keyword called this, we can do something like this. Okay? And I'm going to explain exactly what this means in just a second. Model. So what does this mean? This references kind of this specific class, okay? So when we created this new phone, this is referencing the specific Samsung phone. So if we created a phone, we're saying the make that you've passed in and the model you've passed it, map it to these properties. So when you create the object, these properties here will already be set. Let me show you an example. So now let's say we wanted to create an Apple phone, okay? So let's do phone, and let's just put iPhone, okay? Like that. and if we did new phone, if you press Command P, it shows you that you've got one constructor that takes no parameters, or you've got another constructor that takes the make and the model. So if I left it like this, that's absolutely fine. That's following this same thing here. But what I can do is I can create this object already with the make and model. So the make here is Apple, and the model here, let's just say 13, the iPhone 13. Yep. So now if I print it out, let's do make and type in iPhone.make. Let's just do make for now, and if I run this, notice here it's already actually taken in the fact that we've set the make. So it's already got Apple straight out the box, whereas for this constructor we've had to set these manually, right? So this is how you can use a constructor. You can have as many constructors as you want, and if you're using IntelliJ, even better. If you press Command and N for Mac, you got an option to create a constructor directly here. So if you click enter at constructor, notice here you've got all your properties, and if you select them all and click OK, we've now created a constructor that takes the make, that takes the model, color, and screen size. So now if we generate a new phone, what's another good example of a phone? Let's do another Android phone. So let's do a OnePlus, and let's do a new phone. Now can you see that there's 3 constructors? We can either create a phone without any property set, we can create a phone with just 2 property set, or we can create a phone with every property set, right? So if you press Command P, it tells you the order. So make is OnePlus, the model is, let's just put Nord, the color is, let's just say black, and the screen size, which is a double, let's just say it's 6.5 inches. And there we go, we've actually now generated kind of all of the properties we need in one go, right? So if I change this to OnePlus, change this to OnePlus, just to show you that these have definitely been set. I know it's just 2 properties, but you can imagine that we've got quite a few properties that we've set here, and notice here it's printed it out. So that's what a constructor is. But going back to the point about encapsulation, right? Do we want people to be able to change the make and model? Or do we want people to access these properties directly? I don't think that's very safe, you know, because very easily, you know, we can change these properties, right? We haven't actually given people access to change these properties. We've just said straight out the box, when you create a phone object, yeah, go crazy. You know, you want to set the color, you want to set the screen size. It's as easy as now doing, you know, out blue, we could say, let's change the color now to white. Right, and we've changed the property just like that, right? We've given access. Well, we've not even given access. It's just out the box. So what's encapsulation? So what I'm going to do is I'm going to delete this. Encapsulation is simply, let's go back to the phone class, is making these private. And this is another example of encapsulation. So I'm making these private, just like this, and we'll do the same for this. If we go to our main method now, and if we do, let me undo that deleting. Let's leave this like this. Notice there that these are now red. The reason why is because it's private, you don't have access to this anymore. So when you create an object, you now no longer have access to the properties directly like themselves. So what we have to do is we have to use something called getters and setters. It's as simple as allowing people to get a value or set a value. So right now we can't even set a value, and we also can't print the value out. So if I try to do, see, look, I don't have access to anything. So if I did color, I don't have access to it. But what I can do is provide getters and setters. So let me show you how to do that. So first of all, the way to type it out, let's make this a bit bigger for you guys, is by using literally by writing string. Well, first of all, we make it public. Public string get. Now look, IntelliJ is even being quite kind and trying to fill this in. So let's say the make. We can do this, and then we can write return make. So this way we are specifically giving access to people to the make property. They can't change it. So now what you can do here is you can do Samsung.getMake, and now you can print out the make, right? And the same way for setting it, you have to do public void set make, and here we need to accept a make, right? And then we can do something like this. Okay, so now we have access to the make. So instead of doing Samsung phone.make, we can do Samsung phone.setMake and give it the make we want, like this. So if I delete this and this, and if I copy this line before we set it, and if we run this now, let's have a look. So at the start there was no make because we've just created an empty phone object with no property set, so that's why we got null. Null just means empty or nothing. And now we've called the setMake method that we've created here, and what we've done is we've been able to assign the make Samsung, but this is because we've let the user do it, right? We've specifically said, yes, that's fine, we're going to give you access to make, you can set it and you can get it. And that's why the getter worked here, because we set it here before. So it's as simple as that. Now you might be thinking that might be a long process, you know, if you had so many properties, right? Because look, we've got 4 properties here, we have to kind of write 8 methods. But again, IntelliJ is a gem, so if you press Command N, you'll notice we've got getter and we've got setter. You've even got getter and setter. So if we click getter and setter and select all of these and click OK, just like magic, IntelliJ has generated all of the stuff that we need, and it has generated everything. So now if we go here, you'll see we have access to setMake, getMake, getColor, getModel, getScreenSize, etc, etc. But you won't see access to the actual property itself. And that's because, let's say we created a constructor, right, like we have here. Let's say we've created a phone with the make and model already defined. So let's do the iPhone again. So let's do iPhone equals new iPhone, and let's create it with Apple. And let's do 13 again, okay? But now, what if someone did this? 13 Pro. You know, like maybe we don't want them to change the model after it's been created, right? In that case, it's as simple as getting rid of the setter. So if we got rid of this setter here, they can't do it. But it's still got provided a model, right? So you could still do iPhone.getModel. Because you've allowed them to set it here, but by not providing a setter, you know, you've not allowed them to overwrite what's been given. So this is the beauty of encapsulation, is you can physically control what the client has access to. You know, do they have access to change make? Do they have access to change the color? You know, etc, etc. And it's very important that by making these private, they can only be accessed in this file right here. That's why we can do all this, you know. That's why we can return make, because we have access to it in this file. That's what private means. It means you can't access it externally. That's why we don't have access to the make and model directly. We have to go through get and set. Very simple concept, and it's used everywhere. Okay, so that's one massive pillar of object-oriented programming. Now the next concept I'm going to show you is inheritance. Now inheritance is great, okay? So what I'm going to do is I'm going to actually use a different example, and I'm going to make this one a little bit more fun. So let's create a new class, and I'm going to call this class a villain. Okay, and now a villain, as we've now learned from encapsulation, we're going to keep all of the properties private, but a villain has properties such as, I don't know, let's do evilness. Okay, and that's just one property. Let's do a method as well. So villains also have a catchphrase. Okay, And let's just add a default one for now. Let's just do ha ha ha, I am evil. Interesting one, but there you go. So all villains that we know have a percentage of evilness, and they have an evil catchphrase. Okay, so just like normal, let's create a villain object. So we do villain because we're referencing the class, so this would be the type of object we're creating, and let's give this villain a name. Let's call Bob. It's not a very evil name, but let's go for it. So Bob is a villain, and to make sure he gets created from the villain blueprint even, we go new villain, and there we go. So now if we do bob.catchphrase and run this, ha ha ha, I'm evil, there we go. And we can even, remember, we've got to access evilness, we got to do some getters and setters, just like that. And maybe we can do bob.set evilness as 100. Okay, so now Bob has been created. He's a villain who's very, very evil, clearly, 100. We'll just say it's 100 out of 100. And his catchphrase is, ha ha ha, I am evil. Okay, now let's create a new villain. So let's create a new class, okay? And I'm going to call this villain, well, it's a very famous one. Let's do Darth Vader. Okay, now Darth Vader also has evilness, okay? So let's do evilness, just like that. And Darth Vader also has a lightsaber. We'll just make it a string for now. Doesn't make sense for a lightsaber to be a string, but oh well. And we can do private list of string for okay, we got import. So let's do option enter. Option enter will just import list, because list is in a different package that needs to be imported. So a list of string is just, again, it's a collection of strings but stored in one variable, and we're going to call this force abilities. Okay, and let's initialize the list here. So we've got to create an empty list to start with. Okay, so Darth Vader's got evilness, lightsaber, and guess what? He also has a catchphrase. So let's do public void catchphrase, and his catchphrase would be let's say, sorry if you're a Star Wars fan and if I've got this wrong, you do not understand the power of the dark side of the Force. Bit wordy. We'll just leave it at that. Just checking. Yeah, so we've got, I have not made this public, but notice how that works, because by default, I believe you can view these methods in the same package or folder, but it's make sure to make these public so they're accessible from anywhere in the code. Only the ones that you want, right? You don't want to give people access to things they shouldn't really have. So Darth Vader has now been created. So now what we can do is, in our main method, let's create Darth Vader. So let's do Darth Vader equals new Darth Vader, just like that. And let's do Darth Vader dot set. Oh, there we go. Haven't created any getters and setters, but did you see how good that was? Notice I didn't have access to anything. Good, because I want to be in control of what people have access to. So let's do Darth Vader dot get. Well, let's set evilness first. Set evilness 100 as well. I guess he's as evil as Bob. Let's do Darth Vader dot set lightsaber, and we're just going to write red. It's kind of a given, but, and maybe we can do Darth Vader dot set force abilities. Now, quick way of creating a list, we can do list dot of, and now we can give the things. So he's got choke. He's got, let's give him pull. Let's give him push. That'll do, right? That will absolutely do. Okay. Now, you might be noticing something. A villain has got evilness already, and it's already got a method called catchphrase. I've actually repeated that code here. Notice I've got evilness. I've got catchphrase again, which I haven't even called. So let's do that. Like that. And if I run this, so notice how the villain, Bob, says, haha, I'm evil, whereas Darth Vader says, you do not understand. Oh god, I made a bit of a mistake there. You do not understand the power of the dark side of the Force. Okay, but now let's keep going. Let's create more villains, right? We can go on forever, but the truth is we're going to be repeating this line, and we're going to repeat this line, as well as the getters and setters for evilness. So the best thing to do is create a base class, which we've already done. We've called this villain. That's very generic, right? So Darth Vader is a villain. So we can do something really, really cool. So let's delete evilness. Let's delete these getters and setters for evilness. And instead, let's write extends villain. Now, if I get rid of extends villain just temporarily, let's have a look at the main method. Ooh, you can't do that. Okay, even catchphrase. Let's comment that out for a second. Okay, and notice here we now no longer have access to set evilness or catchphrase. But if we now go to Darth Vader and click extends villain, let's have a look at the code now. Oh, it's back. Because what we're saying is Darth Vader is also a villain. So Darth Vader now has access to evilness and to catchphrase, as well as the getters and setters. Because Darth Vader is a villain, right? There's no need to repeat evilness or catchphrase because Darth Vader, villain, already has it. Okay, so now by adding extends villain, this class has access to everything in this class. Now, one thing you'll notice is if I press run now, Darth Vader is saying, ha ha ha, I am evil. Okay, but if we uncomment this out now, and if we add an annotation called override, let's have a look at what happens. Run. Boom. So now Darth Vader says his catchphrase, and the reason why is if we wanted to use the main method, so the main method here is villain, this is also known as a superclass or a parent class, because Darth Vader in this instance is a child of villain, because it extends villain, it inherits all the properties a villain has, kind of like a child inherits from their parent. So if we didn't have this override, it would use the parent class's catchphrase, which is why before I added this @override and this method, it was copying, it was just using this. Okay, and if you want access to your parent class's code, all you have to do is write super, and now super is referencing villain. So now if you do dot, this is all from villain. And to prove that, before we print out you did not understand the power of the dark side of the force, let's also call this catchphrase method from villain directly inside Darth Vader. So if we run that, and there you go, notice here it's printed this before it's done this. So that is how you can access the main class's code if you ever need it, is by doing super dot, because villain is the superclass, whereas Darth Vader is the child class for the parent of villain, right? And you can do this for everything right now. See, notice how we saved a few lines of code by not repeating it. In real world scenarios, you might have different versions of the same thing. You don't want to be repeating all those getters and setters. You don't want to be repeating any unnecessary code. But just for completion's sake, let's write Voldemort. Okay, and Voldemort, let's directly do extends villain, because Voldemort is also a villain. So we're keeping everything relevant, and it all makes sense to whoever's reading this piece of code. So not only do we now have we've already got access. So right now, if I create Voldemort, oh god, that is not Voldemort. Voldemort equals new Voldemort. Without writing a single line of code, have a look at this. We've got catchphrase, we've got evilness. So let's just comment these out for now. So out of the box, Voldemort can already say a catchphrase and already can set its evilness and everything like that. But obviously for here, we want something specific to Voldemort, right? So private string wand type. Okay, you got private, maybe list of string again. List of string spells, right? And then you want its own getters and setters for that, like that. So again, now Voldemort has Voldemort specific things. See, you got get spells, get one type, whereas Darth Vader will have only things related to Darth Vader. It doesn't have, Darth Vader does not have one type. It doesn't have spells. Rather, it has force abilities. So this is exactly why object-oriented programming is so popular, because it all makes so much sense by grouping related properties and related methods kind of in one area and manipulating the data by using getters and setters and doing all sorts of stuff like that and creating different versions. Now this leads on really nicely to another pillar of object-oriented programming, and that is polymorphism. So polymorphism, believe it or not, we've already seen it. Poly literally means many, so it's basically many versions of the same thing. So for example, we've got catchphrase. We've got catchphrase in 3 different areas right now. Okay, well 2. So let's come in here and do Command N, and that opens this little menu. I think it's Control N if you're on Windows, by the way. If you click on Override Methods here and click Enter, and let's select catchphrase at the top and click Enter. Notice here, this has already generated our override, but notice here, it's got the super catchphrase, because just as a placeholder, it's putting the original code in here. And now we can do something different. So let's call this Harry Potter, the boy who lived. Hopefully you are reading this in Voldemort's voice. So now notice here we've got Bob.catchphrase, Darth Vader.catchphrase, and Voldemort.catchphrase. It's the same exact catchphrase method in 3 different forms. And that's polymorphism. You've created different versions of the same thing, and they all behave completely differently. See, you've got, oh wait, yeah, I forgot that this guy has also got this line in there. Let's delete that and rerun that. And look, you've got 3 different implementations of the exact same method, right? They all behave differently depending on which object it has come from. Even though these all come from Villain, they are completely unique and fit their own purpose. Okay. Another version of polymorphism is method overloading. Now you might be thinking, what the heck is overloading, you know? So let's create a new class. Oh god, I've clicked something I shouldn't have, but let's do a new class, and let's call this calculator. Okay, and I'm gonna actually delete everything I've had here. Okay, now a calculator is just a class. We can do loads of methods on it, right? We're not gonna go and add properties or anything. This is just gonna act like a calculator. Okay, so what can a calculator do? Well, you can do adding, timesing, all of that jazz. So let's do add. So let's do a void method called add, and it takes in an integer 1, number 1, and it also takes an integer number 2. Okay, and then simply it will print number 1 plus number 2. Okay, just like that. So now let's create a calculator object. So this should be like clockwork for you guys now. So you do calculator, maybe we'll call it my calc. So you just got to give it any name you want. New calculator. And now let's do calculator. Let's perform add, and let's give it numbers 45 and 98. Very random, but why not? Let's press run. And there you go. It's added it up for us, okay? So that's great. We've got an add method. Now let's do some polymorphism in terms of, let's do an add method that looks exactly, or is called exactly the same thing but behaves differently. That's what polymorphism is, different versions of the same thing. So let's do void add, and let's do int number 1, int number 2. Now this won't work because there's already one that exists that looks exactly the same, right? Java's not going to know which one to call, because what if this one did something different? It's not going to know. But you can have methods called the exact same thing as long as you make it slightly different. So there we go. So because this one takes in 2 arguments and this one takes in 3, you're allowed to keep the same method name. So we can have 2 methods called add. So this is also a version of polymorphism because we've got different versions of the same thing. So as a client using the code, oh god, I just realized what I've done. As a client using the code, if you did mycalc.add, look at that, you've got 2 add methods and they work slightly differently, and it's a lot cleaner as well, right? Because you know it it's just easy to see, and you can have as many as you want as long as they're different, right? You can do void add again. So this is another example, and this time we can take doubles. Number 1, double number 2. Okay, and this can do celt, and number 1, number 2. Why doesn't it like that? Oh god, every time. Just like that, okay? So now if we go to main, we have now 3 of them. And they all behave differently, because this is adding doubles, this is adding 3 numbers, and this is adding 2 numbers, but they're all called add. So many versions of the same thing. You're now a master of polymorphism. Congratulations. Now the next concept, and I've saved this for last on purpose to see if you still got energy for it, it's abstraction. And it does sound horrible. I absolutely understand that it does not sound friendly, and it's one of those concepts which make you think a little bit. So the best way to explain abstraction is, let's go back to the mobile phone. When you're using a mobile phone, do you ever stop and think of how this works? Most likely not, right? You click on the turn on button and the phone turns on. You don't really care how it turns on as long as it turns on, right? When you're taking a picture on your mobile phone, you press the little picture button. You don't care what's going on behind the scenes. You just know that it will 100% take a picture and you can open it in your gallery. And that is abstraction. The fact that you don't know how it does something, but you know what it does. It's an example of abstraction. And I think the simplest way to describe it is by using interfaces. So what we're going to do, what we've just done with calculator is a great example of how we can abstract exactly what we've done here. So let's create a new class, but this time we're going to select interface. Okay, so let's call this calculator interface. Okay, or do you know what? A better way of writing this is maybe let's just call it calculator service. But it is an interface, okay? And this is all an interface is. Instead of saying class, this says interface. Now you can't create an object from an interface. So if we go to main, we cannot do calculator service equals new calculator service. See, it just doesn't work, okay? You cannot do that. What you have to do is implement an interface. Because remember I told you it's about not knowing how something works, but knowing what it does. So let me show you exactly what that means. Notice how here we've written out the method name, the parameters it takes, as well as the implementation. Basically, all you're doing is getting rid of this, because this tells you how it adds, right? This is showing the internal mechanics of how it adds. So, for example, we will just do public void. In fact, you don't even need public, because an interface is public by default, because you can do public void add, and you can do int, let's say int num1, int num2. You're done. Literally, that's it. And you know, if you wanted to do kind of what we were doing before, int num3. That is an interface. Now you might be writing, well, Neil, how do you actually add the code, right? Well, where's the code that does the adding? Okay, so what we have to do is let's create a new class, and we're going to call this calculator service. And the good convention here is impl. Impl means implementation. If you ever see a class that has the name impl at the end, that means it uses the interface. So to use this interface, we literally have to write implements. Implements is another keyword, and what that means is you have to give it an interface now. So we've created our calculator service, and now notice that it's gone red. The reason why it's red is because we're implementing these two methods, okay? And at the moment, it can't see us doing those 2 methods. So if you hover over this, if you select implement methods and click OK, it's now created the methods that we are abstracting. So this is abstracting. You are telling whoever uses this calculator service, you're telling them you're going to add 2 numbers. You don't care how, and you don't care, like what process they use. You can be quite confident that this method will return a void. Let's go back here. We'll return a void. Let's get rid of public as well. As I said, you don't need it, but you're very confident that this will add this number and this number, or this will add this number, this number, this number, and you don't care how, you just know it will do it, right? So this is abstracting. You're telling something what it does without giving away the details. So this is great for security, and this is great for your clients just to be able to have a quick glance. You know, imagine you had a lot of code in this, you know, it makes this file a bit hard to read. You know, just imagine this is really good coding, and now imagine, you know, imagine this file also looked like that, and then so on and so on. It makes it quite hard to, you know, you have to do a lot of scrolling to see what things do, you know, what methods are there. So essentially what we do now is do exactly what we did here in this other method. So let's copy this like that. Oh yeah, this is num1 and this is num2. Okay, and we'll do the same down below. num1 plus num2 plus num3. Okay, and the beauty of an interface is you can have different versions of it. So this might be your first, you know, like this is, oh yeah, cool, this is how I'm adding stuff. Okay, but now let's create a new file called I'm gonna call it calculator service impl. I'm actually gonna put new at the front. So let's say someone's come along and says, well, I can do that differently, or maybe you have a requirement to do something slightly differently. Oh, I've made it a class, but let's make this. Oh wait, no, that is right, because what we're going to do is we're going to implement the calculator service again, but now we can do things differently. Maybe we do, I don't know, let's create a variable called result, and then do num1 plus num2, and then do print out. You know, see what I mean? We're doing the same thing. We're just, instead of doing this in here, we just moved it out. And same here, right? Int result is num1 plus num2. Let's just do this even worse. Plus equals result plus num3. And now we print out result. I mean, doesn't really make sense to do it this way, but I'm just showing how you can have a service here, a calculator service, which is an interface, which just tells you it's going to add this number and this number. This just tells you it's going to add this number, and this number. What you can see here is one implementation of it, and this is another implementation of it. So in your main method now, you can do calculator service equals, and you can take your pick which one you want to use. You can use calculator service impl or new calculator service impl, whichever one. So let's use the original one that we created, and now we can do calculator service dot add. See, we got the methods there, and let's do 34 and 78. Let's do the other one, which is 12 this plus this, and we can also create another object, calculator service, and do calculator service 1 equals new calculator service. Bit of a mouthful there. And we can do exactly the same thing because we've abstracted it. We know exactly, you know, we can go to add and we can choose, you know, which one we're using. Oh, let's say here we can click on add. Notice how it didn't take us to the actual file where the code was implemented. It actually took us directly to the service file. So, you know, let's do that again for this one. It took us to the interface, because all you care about is what it takes, what it returns. You don't really care how it does it. The method name will tell you what it does, right? So here we can let's do this and this. We can do the last one. Oh wait, I just realized this is referencing the old one. And let's do this one. 1256. Get rid of that dot. And if I comment this stuff out, let's give this a run. And there we go. There's our hopefully correct code. If you guys want to go and calculate this and see if it's right, go for it. But what we've just done is we've just done abstraction. This is literally abstract because this doesn't tell you how it does it, right? It just tells you what it does, what it returns, you know, what it needs. Whereas this is where you put your implementation. This is where you actually write the business logic or your code to actually do the adding. And this is, you know, by writing implements, you can do it again wherever. And the beauty of this is you can actually do multiple. you know. So you could, if I just copy this calculator service again and call it new calculator service, and instead of doing add, I can do minus and make this one minus. So this calculator service implements this calculator service as well as new calculator service, and now it's going to complain because I don't have minus implemented. So if I click minus, and there we go. So now we're reusing the exact same methods, so we're not writing completely brand new methods, and we can, you know, do everything as we did just before. We could do minus num2 like that, and same here. Num1 minus 9 num2 minus num3, I guess. And now this specific calculator has access to that. Dot. Right, maybe not this one. It might be the one below it. Let's have a look. There's no one. Where are they? Where is it? Ah. Oh, right. Reason why that didn't work is because we've equaled it to calculator service. So if you had put the actual object here, we would have access to minus. Okay, there we go. Hiccups happen. It's all part of the journey. So now we can do this. So there you go. So you have to be very careful. So it makes sense to just use the impl file to create your object. Same exact way as we did before. You don't have to use the interface because that will restrict it to this specific interface, because you're saying that this is a version of this in a way, you know, you're assigning it to your interface here, so it's only got access to these two. Whereas by assigning it to the file calculator service impl, you're saying it's of type this, and you've got access to add, minus, minus. There we go. So that is object-oriented programming in a nutshell. And you know, you can go crazy with this kind of thing, and you can have a fun with it. I would definitely recommend doing some practicing on this. So maybe just create some, maybe pick your favorite object, or pick an object in your room and try and program it, try and build it in Java. So you know, you could have just something weird like a laptop, create a laptop class, and then maybe to test inheritance, maybe create a MacBook that inherits a laptop but also has specific things, such as, I don't know, what do MacBooks have differently? The Mac OS version, or you know, you can extend a laptop and do a Surface tablet, so that doesn't have a keyboard. So you can kind of play around and create different objects and play around with different properties, and make sure to use encapsulation, so that way you can protect your properties, so no one can access these directly. They have to access it through getters and setters, which you provide. And remember to use Command and N to help generate everything for you. You can use constructors to create objects very quickly, like you saw with the phone, where we could create an object directly with the model, make and color, for example. And yeah, have fun with it, practice, and build yourself a nice object-oriented application. So yeah, that was my video, and thank you so much for watching. If you enjoyed this video, please give it a thumbs up, and don't forget to subscribe if you're enjoying yourself on my channel, as I'll be posting new videos weekly. If you have any suggestions, or if there's any topics you want me to cover, please leave a comment down below. Thank you guys.